Good morning and a very good day, everyone. Welcome to our Chapter 2 lecture. And for this week, topic is on the VR input devices. Before we go into deeper onto our this week topic, so let's recap back what we have learned last week. Okay, on Chapter 1, we have covered on the introduction to VR. Okay, we covered on the definition of what is VR, and also we learned about a brief history of VR and also the type of VR, which consists of 5 type of VR, and we also covered on the technologies of VR, which covered on the both hardware and also software, the architecture of VR system, and also we have a brief introduction to what are the application of the VR in the various field, and also we also discuss on the current problem and future work of the VR technology. So let's look into this week topic. Okay, what we're gonna cover inside this topic. So at the end of the chapter, you should be able to understand on the what is virtual reality triangles, or we call the other name of this virtual reality triangle as the I3. Okay, I power of 3. And also you also we covered on the requirement for the system. What are the requirement for the VR system? In some introduction to the input devices. What is the degree of freedoms when it comes to the input devices, and also we covered on the so what is virtual reality triangles. Okay, the other name of this virtual reality triangles is the I3. So this I3 consists of the first I, which is immersions, the second I is the interactions, and the third I is the imagination. So all of these three components can be considered as the features of virtual reality technology. Okay, it consists of immersion, interaction, and imagination. So let's look into what is immersion. Okay, what is immersion? We can say that immersion is the something that gives you a feeling of being there. Okay, immersion into a VR giving the sensation of being there. You are feeling that you are really in that virtual reality environments. Or the other term of the immersion is something that involve your deep mental. Okay, a deep mental involvement in something. That means you are feelings that you are really in that kind of virtual reality environment. Immerse you in that VR environment. And the second I is the interaction. Okay, what is interaction? Interaction when it's come to the virtual reality environment is dealing with something that you can interact with the object in the virtual reality environment through the navigation or manipulation. Okay, you can navigate into that VR environment, and also you can manipulate with the object inside that virtual environment. Okay, this is about interaction, how you interact with the object and also environment in that virtual world. And the third I that the features of virtuality consists of imagination. Okay, what is imagination? When it's come to the human imagination, so basically is dealing with the ability of us or the willingness of us to accept the contribution of the VR to solve the real world problems. Okay, so we are feeling that the virtual reality is something that can help us or contribute to solve the real world problem is our imagination. Okay, to believe that VR can solve the real world problem. So this is the 3I. Okay, I3: immersion, interaction, and imagination. Let's look into the details of the 3I of VR, that we have immersions, interaction, and imagination. So what is immersion? Like I mentioned previously, immersion is something that dealing about the feeling of presence. Okay, present is feeling of being there. You are feeling that you are really into that world. You are feeling that you are being there in that VR environments. It consists of the amount of quality of stimuli and sensation. Okay, there is a action and also the response from the user and also from the virtual reality environments. And also immersion is also dealing with the real-time interaction. Okay, real time. So we have to make sure that our VR system have a very little latency. Okay, what is latency? Basically, latency is the time delay between the action and results. So we need to make sure that we need to achieve a very little latency because we want to avoid the delay time between action and result. For example, if you're doing some action in the real world, you will need to see that action in the virtual world in the real time. Okay, if delay, you feel dizziness or the cyber sickness when there is a delay from the action and the result in the virtual world. And the suggested times for to achieve the very little latency is 50 millisecond. Okay, is among the suggested time for the visual noticeability, okay, in the VR environment. And the second I is the interaction. Based on the name itself, interact, okay, is something that you need to deal with the virtual object and also the interaction inside virtual environment. So it's not just a passive watching. Okay, when you enter the virtual environment, it's not like you are just there watching. Okay, so we have to make sure that our virtual reality environments is something that have some active participation from the user. For example, you can move in the virtual world and also doing all kind of thing there, like manipulate the object inside there, not just passive watching. And the third one is about imagination. So it's about the application of the VR itself, the ideas of how the stimuli and also the action inside that virtual reality environment, and also about the virtual world itself. Okay, how we imagine all of these components are related to each other and how it can solve the real world problems. Okay, so this is the 3 I of virtual reality features: immersion, interaction, and imagination. All right, let's move into the VR input devices. Okay, what is input devices? In computing, an input device is a piece of equipment that we can use to provide data and control signal to an information processing system such as computer or information appliance. Okay, but when it's come to the VR input devices, it can refer to the physical devices. Okay, it's a physical device that can convey an information or to give information into the application, and also it can support the interaction in the virtual environment. Okay, it's have the same function like other input devices, but for VR it can use to convey the information, okay, to support the information, to give the information to the application, and also can support the interaction, but specifically in the virtual environment. So let's find out what are those input that can be used to support the VR interaction. Before we go into the deeper of the virtuality input devices, let's look at this two figures here. Okay, on my left hand side here is the user interface for the desktop, and on my right hand side here is the VR environments. Okay, is the VR environment. So for input devices that we can use to interact with the desktop user interface on my left hand side here, we can use the input devices such as mouse and also keyboard. Okay, is amongst the good input devices for the desktop user interface task. For the text entry, for example, for the selection, for the drag and drop, scrolling, and so on. So mouse and keyboard are amongst the input devices that we can use to interact with the desktop user interface. So how about VR environments? What are the input devices that we can use? Okay, what are the devices that are best for the 3D input in virtual reality environments? Do we need to use some new type of device? So let's find out what are the devices that we can use as a input devices for the virtual reality environments. The first category of the VR input devices that we can use to interact with the virtual reality environments is the hand input devices. Okay, this is the first category of the VR input devices, which is the hand input devices. So when it's come to the word hand here, of course, if we're dealing with the device that use hands. Okay, device that integrate hand input into VR. Okay, it's a device or physical device that can integrate your hand as an input into the VR environment. And this first category have many type of the hand input devices. Okay, we have world grounded input devices. Okay, as the first type of the hand input. Okay, world grounded input devices is a device that fixed in the real world. For example, joystick. Okay, is fixed to the real world. And the second type of the hand input devices is the non-track handheld controller. Okay, non-track, so it's no tracking. It's device held in hand but not tracked in 3D. Okay, for example, Xbox controller. And the third type of hand input devices is the track handheld controller. Okay, this one is a physical device with 6 degrees of freedom tracking inside. For example, Vive controller. Okay, I will explain about this degree of freedoms in the next slide. What is DOF or degree of freedoms? And the fourth type of the hand input devices is the hand-worn devices. Okay, hand-worn devices is a device that will be worn by your hand. Okay, will be wear by your hands. For example, a glove, rings, or device that worn by hand or your arms. And the fifth type of your hand input devices is the bare hand input. Okay, bare hand. It means just use your bare hand, nothing to be worn by your hands. Okay, using technologies that to recognize the natural hand input without wearing anything, bare hand. In the previous slide, there is a term DOF. Okay, DOF basically refer to the degree of freedoms. And what is degree of freedoms means here is that is refer to the freedom of movement. Okay, the freedom of the movement, the freedom of the controlling the object or the devices in three-dimensional space. Okay, specifically, it means that we can freely change the position whether we want to go forward or backward, up or down, left or right, or transition in three perpendicular axes. Okay, with combined with the changes in orientation, rotation, and so on. Okay, this is the DOF or degree of freedom means. Okay, when it's come to the 6 DOF or 6 degree of freedom, what that device can control or can use is it can either moving up or down, moving left or right, moving forward and backward, tilting forward and backward, turning left or right, or tilting side to side or rolling. Okay, so here are the 6 degree of freedoms that the user can use, okay, to control that devices. Okay, you have a freely to change the positions. Let's look into the first category of the hand input devices, which is the world grounded devices. Okay, the world grounded devices. So basically this world grounded devices is a device that constrain or fit in the real world. Okay, if you look at this figure down here, okay, this is the VR application for the Disney Aladdin Magic Carpet VR ride. So you look into the device that this user is holding. Okay, basically this device is constrained or fixed in the world. It cannot move to the any other place. That's why it's fall under category of the world grounded device because it's fixed in the real world. It cannot move up or down. Okay, it just can control at this fixed area only. And this type of devices is not ideal for VR. It's not suitable for VR because it can constrain the user motion. Okay, it's hard for the user to move around because the user can only move this controller only. Okay, so it's constrained for the user motion or the movement. But it's good for the VR that involve the vehicle metaphor. For example, is used in the location-based entertainment. For example, in the Disney Aladdin ride, where the user can ride this carpet, okay, this Aladdin carpet, just on the fixed area or fixed location on this, okay, something that is suitable for the VR that have the location-based, okay, location-based entertainment, something like in the Disney Aladdin Magic Carpet. Okay, this is the first category of the hand input devices, which is the world grounded device. Is the device that fit in the real world. The second type of the hand input devices is the non-tracked handheld controller. Okay, non-track handheld controller, based on the name itself, is a non-track, so it's mean no tracking. Okay, it's a handheld controller with no tracking, and this device is held in hand. Okay, you use your hand to control the devices. And among the features or the example of these devices of this non-track is something like that have buttons, okay, the joystick, the game controller, and etc. I think all of the gamers in this class, you familiar with the joystick and game controllers, right? And among the traditional video game controller is like Xbox controller. Okay, so Xbox controller, joystick, game controller, all of these things are fall under category of the non-track handheld controller. Okay, it has no tracking, but it's used can use to control the games and so on. The third type of the hand input devices is the category of track handheld controllers. Okay, before this we have the non-track, but this one is the track handheld controller. When it's come to the track, of course, it will involve tracking. Okay, handheld controller with 6 degree of freedom tracking. They combine the button and joystick input plus trackings. Okay, so based on these features here, this handheld controller have 6 degree of freedom of tracking. Okay, it can move 6 degree of freedom. It can also combine the buttons and also the joystick input and also the tracking. Okay, based on this figure on my right hand side here, this is the example of the track handheld controllers where you can use your hand to track this, and you can also use this as a virtual reality environment interaction. Okay, and this track handheld controllers is one of the input devices that is the best option for the VR application because it can enhance the presence. Okay, the enhance the feel of the feeling there. Okay, you are truly feeling in that VR environments, and is provide proprioceptive or passive haptic touch cue. Okay, proprioceptive means here is that the feelings of is also called kinesthesia, is a body ability to sense its location, the movement, and also actions. Okay, it's a sense of self movement and body position is sometimes described as the sixth sense. Okay, something that you know what to do. Okay, by using this track handheld controllers, and also is direct mapping to the real hand motion. Okay, it's direct because it's use hand to control, so of course it will direct to your hand movement. Okay, it's really controlled by your hand movement. To understand more on this track handheld controller, so let's look into this demo video of this light cyber demo with the 6 sense stem. Okay, 6 sense is one of the technology of this tracked handheld. So let's look into this example to understand more of these features or this function of this track handheld.
We're here at GDC 2015, and we just tried a 6 sense demo. We missed it last year. They've done some refinement. This is a new version. It's a lightsaber demo.
Right, so 6 sense is it's a motion tracker. They did a Kickstarter, and they basically built that technology behind, for example, the Hydra, where you have controllers you can hold up the sensor of the base station, and it
uses a magnetic field to tell position in 3D space. So it's not using gyroscopes, accelerometers, any of that kind of stuff. And you get 6 degrees. You get lateral movement, orientation, the whole thing, at a very high pace, like 4 milliseconds per frame. So like 240 hertz updates, which is really good.
The latency is good, and also really the precision is good. This demo did a few things. The demo showed 6 sense in VR standing up, which we haven't done before. It's still a tethered experience, but some things they've built into the demo, for example, boundaries. We talked about this before. If you're going to be doing VR, sitting up or standing down in your room, how do you know where your furniture is? Now, if there was a camera mapping the room, that would be easy. But there's no camera built in the system, so you can do your own mapping yourself.
So yeah, one of the things that they do with the newer version of the dev kit that they've been sending out to Kickstarter backers is when you get it, you move this without the goggles on. You move the sensor around the place that you want to be active, and then when you get up near the edge of it, it gives you this kind of subtle red grid. It looks like a force field effect from like last car.
Beside handheld input devices, what we have to use as the input devices for virtual reality environment is the cubic mouse. Okay, what is cubic mouse? Cubic mouse is like a plastic box. Okay, like you see in my figure on my right hand side here is a plastic box here with 6 button, 1 2 3 4 5 6 button, and then it has 3 translating rod. Okay, you have 3 translating rod here, 1 rod, 2 rod, 3 rod. Okay, so have 3 translating rod here to control the 3D object with 6 button. Okay, and also it have a 6 degree of freedom tracking, and is used to support the object rotation. Okay, it can use to rotate the 3D object. It also can use for the zooming, to zoom in and zoom out of the virtual object, to cutting plane, and etc. Okay, let's look into the next video for more understanding on how this cubic mouse is working.
In this visualization of a finite element model for a crash simulation, the cubic mouse controls the positions of the 3 orthogonal clipping planes. Here we push one of the clipping planes from the top into the car. The buttons on the ends of the rods toggle the orientation of the clipping planes. Now we switch to a so-called chair cut, where one octant of the car model is removed.
The next category of the handheld VR input devices is the hand-worn devices. Okay, hand-worn. So when it's come to the term hand-worn here, it means that it's the device that will be will be worn by your hands or arm. Okay, devices worn on your hands, on your arms. For example of this device is like a glove, a rings, and etc. Okay, you can look into the figures on my right hand side here. Here are some of the example of the hand-worn devices that will be worn by your hand or arms. Okay, and there are some advantages that we can get from using these hand-worn devices. The first advantage is the natural input, okay, with potentially rich gesture interaction. Okay, of course, when it's come to the hand, it's using hand, so basically it's have a lot and a very rich gesture interaction. You can interact with the object inside the virtual environment in a natural way, in a natural interaction, because you can move your hand like in real life. And hands can be held in a comfortable positions, okay, and no line of sight issue, okay, because it's used on your hands, is you are comfortable, you can put anywhere, you can position it anywhere with the comfortable based on your comfort. Okay, and hands and fingers can fully interact with the real object. Yes, okay, you can use these hand-worn devices to fully interact with the real object. You will have a direct contact, okay, a direct interaction, direct contact with the real object in the virtual environment, because you can just use your hands. Example of the hand-worn input devices is like data glove, for example, and this data glove have been categorized into two type of glove, whether it's fall under band sensing glove or pinch glove. Okay, what is band sensing glove? Okay, band here means that it's based on your how your hand is bending. Okay, bagaimana awak punya glove tu boleh dibengkokkan. Okay, tangan tu dibengkokkan. Based on this band sensing, okay, it will detect hand posture and also gesture. Okay, dia akan detect awak punya tangan dari segi posture ke gesture, and the continuous raw data from the band sensor will be input. And this type of band sensing glove have a large degree of freedom output and is natural hand output, because is using hand, of course, it's more natural for us to have this kind of uh, sensing glove or VR devices that using hand. Another type beside band sensing glove, we have the pinch glove. Okay, based on this figure up here is using band sensing based on how you bend your hands. And for the second type is the pinch glove. Okay, pinch glove, pinch mean here is pitch it or press based on your pressings on your fingertips here. Okay, based on the pinch glove, based on your pitch it. Okay, pitchitan, and its conductive material at the fingertips. Yeah, is all the sensing is on these fingertips. Is will determine if the fingertip is touching. Okay, is whether these two fingertips is touch each other. Is will determine based on this touch from these two fingertips. And basically this type of glove using pinch sensing is used for the discrete inputs such as for the object selection, okay, to select the object in the virtual environment, for the mode switching, okay, if you want to change the mode inside the virtual reality environments. Among the example of the glove of the data glove out there in the market is like Cyberglove. Okay, Cyberglove is basically has been developed or invented to support the sign language. Okay, to support the sign language, and it has the technology of bending sensor that will change the resistance, and it has around 18 to 22 sensor per glove with 120 hertz samples. And this kind of Cyberglove is very expensive, which costs more than 10,000 US dollar per glove. Okay, as you look into the example on my right hand side here, there is a hands wearing this Cyberglove, and this Cyberglove will have an effects into the virtual environment. If you look into this is the virtual hands. Okay, inside this virtual environment is really replicate what we have in the real world here. And this is a demo video of how Cyberglove system is working. So let's look into this example of how this Cyberglove is working and functioning. The next type of category for the VR input devices is bare hands category. Okay, based on the name itself, bare hands. So it's solely based on your hand without no need to wear anything on your hands. Okay, it's using computer vision to track the bare hand input, and it can create a compelling sense of the presence. Okay, and it has a natural interaction. Okay. But there is one thing that is challenges that need to be solved when we want to use the bare hand as a VR input device, where it have not having a sense of touch. Okay, because we didn't have anything that we wear from this our bare hand, so we're not gonna feel or have the sense of touch of the any virtual objects in the virtual worlds. Here is the video demo of the lip motion for the hand tracking system. Here is the video demo of the lip motion for the hand tracking system. Let's move into the next category of the VR input device. Before this, we already covered on the handheld input device. So let's look into the next type, which is the non-hand input devices. Okay, based on the name itself, non-hand. Okay, so of course it does not relate to the hand at all. Okay, we don't use hand as an input device like previous devices. So basically in this type of input device, it will capture the input from other part of the body. Okay, instead of using hand, we use other part of the body. So what are the part of the body that we have or we can use as the input devices? We have the category like the head tracking. Okay, head tracking where is use head motion as an input. We also have eye tracking where we're going to use the eye, okay, for as a tracker in the VR environment, largely unexplored for VR. Okay, this one is very rare to be used as a VR input. And then we have microphone, okay, this one for the audio input or speech input. And then we also have full body tracking. Okay, the full body tracking is like the motion capture or body movement. So let's find out each of these in the next slide. Eye trackings. Okay, when it's come to the eye tracking, of course it's dealing with the eye. Okay, if you look into the figures on the right hand side here, okay, this is the software for the to stream the eye camera. Okay, and this technology is using the IR light. Okay, IR is the infrared light. It will shine or focus the infrared light into the eye. Okay, into the eye, and then from the eye it will look for the reflection. And there are some advantages of using eye tracking, which is first is provide natural hand-free input. Okay, so no hands involved. Okay, for this eye tracking, gaze will provide cue as to user as attention. Scene is using the reflection from the infrared light, so it can provide a cues or a sign to become an attention for the user to watch on that. It can be combined with other input technologies. Okay, the eye tracking can be combined with several input technologies to have it more effective. Let's look into this video sample for the VR headset that use eye tracker. Okay, it has integrated the eye tracker into this HMD, head mounted display.
We are on a mission to unlock the essence of reality in virtual worlds, to enable human integration with technology that is so seamless, all it takes is a glance for your digital environment to react at the speed of thought. We are PhOV, the world's first eye-tracking virtual reality headset.
PhOV is pushing the boundaries of what is possible with virtual reality and helping to realize its true potential. We wanted to create the next generation of VR, so we developed the world's most advanced eye tracking technology and are complementing it with a high-resolution screen and low-latency tracking.
As the user perceives the digital environment, PhOV's infrared cameras track their pupils and register the slightest movements. With each expression, glance, and blink, the user's intentions manifest in the virtual world.
Because PhOV knows exactly where the user is looking with imperceptible delay, we can enable a technique called foveated rendering. This allows us to focus the fidelity in the part of the vision that matters most, leading to better performance on lower-end hardware than is currently possible.
By calculating subtle parallax between pupils, PhOV enables software to present virtual environments with realistic depth of field, improving immersion and allowing the eyes to relax when viewing objects at varying depths. And by enabling fine control with the eyes, PhOV significantly reduces simulation sickness through the elimination of unnecessary movements.
Beside eye trackings, we also have the full body tracking as a VR input devices. Okay, if you look into this figure, there is a person here wearing a bodysuit. Okay, and if you look closer, there is some trackings. Okay, some tracking on their body here, on their bodysuit, on each area of this body. Okay, it will add the full body input into the VR. And by using this full body tracking, it can create the illusion of self-embodiment. Okay, the self-embodiment means here that something that you can represent yourself. Okay, in the virtual environment, when you wearing this kind of suit, you will feel that you are really in that virtual world. Okay, the full body that involved in that virtual world. And of course, by having this self-embodiment, it can significantly enhance the sense of presence. Okay, you enhance or increase your sense of being there, the sense of being in the virtual world. And this technologies is consists of the motion capture suit. Okay, this suit that you see from this figure is called a motion capture suit, and then is involved camera-based system. And this area of capturing this body movement is there are a lot of camera involved, okay, to capture this, and it can track a large number of significant feature point. Okay, because it's involved camera based system, it can track a large or huge the feature points of this full body tracking. Like I mentioned before, in the full body tracking system, where it's used the camera based system. So if you look at this camera based motion capture here, it will involve the a person, a user wearing this motion capture bodysuit, okay, like this, and then it has a lot of camera used in the scene. Okay, you have camera here on each of these have the camera base. Okay, it use multiple cameras, and it will have a reflective markers on the body. Okay, so basically to capture this body tracker or body tracking, this bodysuit is basically have some reflective markers here. Okay, it's used to reflect this, okay, onto the camera. Okay, this one is the reflective marker. All of this dot is representing the reflective markers. Okay, and this is the example of the Opitrack demo. Okay, basically is the motion capture session. Beside that, we also have the wearable motion capture. For example, the technology name of this is PrioVR. Okay, and this wearable motion capture system have around 8 to 17 initial sensor, and it can transmit the data through wireless. And when it comes to the wearable motion, it can support a full range of motion, no occlusion. Okay, no occlusion here means that no overlapping between two objects. Okay, you can have a wide variety of the motion. Okay, you can use the full body to move, to rotate, or you can do anything with a very wide range of the motion with no occlusion, with no that you will feel that worry to when two objects are near to each other or it will hit each other. No, you can have a full range of motion when it's come to the wearable motion capture system. Let's have a look at this video for the wearable motion capture to look into how it looks and how it functions. Beside that, we also have the pedestrian input VR devices. Okay, when it comes to the pedestrian, is about walking and running. Okay, it's about walking and running as a input devices in virtuality environments. And in this kind of pedestrian devices is always involved special shoes. For example, okay, we have special shoes, and also we have socks, and also slippery surface. Okay, so that it can support this kind of the pedestrian input devices. If you look into this figure on this right hand side, this is the example of how pedestrian input devices look like. Okay, it have some kind of the special surface, okay, and some kind of the special shoes, and also some socks. Okay, a user is entering the trackball. Okay, the user is entering the trackball and also wearing the HMD inside. And this is the environment that the user is seeing or view inside that HMD. And then the trackball is start to spinning. The user is start to rotate around, walking around, and this is his C. Okay, this one is for entertainment. Okay, you can move around, and this is the environment that they see. Brief. Beside pedestrian devices that can support walking and running for VR, we also have the Virtusphere. Okay, Virtusphere is a fully immersive sphere that can support the walking and running also in virtual reality environments, and is involve a person or a user inside a trackball. Okay, if you look in this figure, this person is in the trackball. This is the trackball. It looks like the hamster ball. Okay, but the user is inside, and then will walking and also running in this to have a fully immersive in the virtual reality environment. This is the example of how this Virtusphere is working. Moreover, we also have the omnidirectional treadmill. Okay, it looks like the normal treadmill, but is actually support as an input devices for the virtual reality. Okay, and this in this example, this omnidirectional treadmill is the Infinadeck. Okay, Infinadeck versions. It have 2 axis treadmill and is made up from the flexible material. And when it's running, okay, when it start working, this treadmill can track the user so that the user will keep themselves in the center of this surface. It have a limitless walking input in VR. Okay, if it have no limit on the walking, and it can be an input in the VR. Okay, it have no limit walking. You can have infinity walking inside this omnidirectional treadmill. Okay, let's look into the next video to have a look on how this omnidirectional treadmill is working.
Welcome to Infinadeck, a true omnidirectional treadmill. Infinadeck uses motorized components and a simple belt connected to a sensor to track and respond to your movements in real time. Infinadeck's belt has multiple bands that change direction, allowing you to go in any direction at your own pace, freeing you to explore your virtual reality environment naturally and safely. Infinadeck revolutionizes virtual reality movement, giving you the ability to quickly change pace, stop and go, crouch and pivot, providing a truly immersive experience. With our technology, you can feel like part of your favorite game, or jog through exotic countryside while at the gym. Infinadeck makes the future possible today. Imagine training simulations that prepare you for urban warfare, let you practice tactics on foreign terrain, or even walk beneath the stars of another world. Infinadeck's omnidirectional treadmill technology makes it possible for you to be fully engaged in the VR world while keeping you safely in the center of the treadmill. There is no limit to where you can go.